there, not seniors. So just you two. So, this chapter 9, is actually about what's known as conic sections, which conic sections are shapes that can be made when you have two cones stacked on top of one another and then sliced through. I forgot, I have a movie that a little video clip that shows this that I forgot. I was going to show you guys first. So, if you have two cones that are stacked on top of one another and you take a cross section of it and you slice through it, the shape that's left, that cross section, is known as a conic section. So one conic section, as you can see, is a circle. But depending on how you make that slice, you could get a parabola, a hyperbola, an ellipse, and then again goes back to a circle. So there's actually a number of different shapes that fit for conic sections. And when it comes to working with conic sections, some of which we've talked about before, parabolas, hyperbolas, you've talked about those in other classes. Yes, I know you've talked about circles, but you're the first group, or the last group, that has never talked about equations for them yet. When you've talked about them in the past, the way that we've approached those different shapes is, well, different than how we do it in reference to actual conic sections, because there's a different definition when you refer to these shapes based on being a cross section of this two cones stacked. So today we're talking about circles. We're going to be, actually, in here, we're really only going to talk about circles and ellipses, because hyperbolas and parabolas, their definitions, the way we work with them is actually a lot more complicated, and we just don't have the time for that. So we're going to focus in circles, ellipses. That's the two shapes you've never talked about in any class before. Now, circle has a couple different definitions. Definition you've worked with in the past is it's the set of all points equidistant from a given point. The current definition is similar, but oftentimes with conic sections, they talk about the locus of points. Equidistant from a given point in a plane. Okay, a couple things to break down about this definition. First off, that given point that you're equidistant from is the center of the circle. It is in a plane because it is a two-dimensional object. It needs to be a flat object. If we didn't have the words in a plane in there, we'd be talking about a sphere. Okay, locus is probably the thing that people are like, please define that one. And it's really comes down to set of all points. It's technically a little more complicated than that, but it's really what it comes down to. When it comes to working with your circles, today's circle is not a good circle. There's some key features that we talk about. Those two segments there are two key ones that come up a lot. Do we remember the names of them? One's a radius, one's a diameter. Or technically, I could say it's 3 radii. Today we're going to be talking about the equation of a circle. Why? Equation of a circle goes x minus h quantity squared plus y minus k quantity squared equals r squared. Now h and k, we've talked about h and k in this class before. We've talked about h and k in previous classes before. H and k typically come up when we talk about transformations, when we talk about moving a graph up, down, left, and right. And the reason for that being is a typical circle, they reference it as being centered at the origin. And then you move it up, down, left, and right based on h and k. In the end, the center ends up being at the coordinate point hk. And I'm guessing it's not shocking to anyone that r is the radius. Now, keep in mind that the formula says x minus h, y minus k. So, keep an eye on if h and k are positive, when you plug them in, you're going to have minus signs. If h and k are negative, when you plug it in, it's going to turn into plus signs. One of the most common things that people make mistakes on is they just overlook the fact that the original formula has minus signs here, or they accidentally put a minus sign between. Between is a plus sign, because the equation of a circle actually comes out of the distance formula. If you think about distance between center and edge of circle, that's this x minus h and y minus k getting squared. That's that innards of the distance formula. The distance formula typically has a square root. Here we just left it as r squared instead of a square root. Okay, so you're going to be asked to do a couple different things today. One thing you're going to be asked to do is identify the center and the radius. Another thing you might be asked to do is to sketch the graph. We're going to put those two things together. Make sure you're reading the instructions as you're going through the assignment today as to which ones you have to sketch the graph and which ones you don't. First one, 81 equals y squared plus in the quantity x plus 2 squared. Now keep in mind that this is not written in the traditional standard form. It is a standard form of an equation, but it's a little bit rearranged. Keep an eye on that. They tend to do that every once in a while to mess with you. If I had this in traditional standard form, I'd have my x's first, and it would be x minus what? X plus 2 is x minus negative 2 quantity squared plus y minus what? 0. If you can't see y minus something, it's 0 that got subtracted. Squared equal to 81, but that's r squared, and r therefore is 9 getting squared. Now you don't have to rewrite this. This is just me kind of showing you things. This is technically a simplified standard form. It's what I would be looking for if I asked for standard form. Yeah, it's maybe in a different order, but that's not the point. But you have to recognize that this and this are equivalent to be able to get your center and your radius. which many of you probably could have done that by just looking at it, and I'm okay with that. What is the center of this circle? Not 2, 0. Negative 2, 0. And if you said that, I just misheard you. So, was a positive, the center's at the negative. There was no plus or minus, it's at 0. And the radius we already established would be 9. Because that's your R. That's your H. That's your K. That's where all that came from. So far, simple enough? Maybe. I don't have the big group to give feedback. I've got a small group. Okay, now we also need to graph it. Now, when it comes to graphing it, people, that tends to be their biggest, just because they're like, I can barely draw a circle, let alone graph a circle correctly. So, generally speaking, you start with your center, and then we work with our radius from there. Now, keeping in mind that if my center is at negative 2, 0, I'm going to need a little bit more room to the left because it moved left 2. That's what the negative 2 did. And with a radius of 9, I'm going to want to make sure that I'm giving myself space to get this. So, I draw my XY axis. To fit a radius of 9 on there, radius of 9 going out from this coordinate point is going to give me, at least to the left, I'm going to need to get to negative 11. To the right, I'm going to need to get to a positive 7, because that's 9 different from each of those. Up and down, I'm just going to have to get up to 9, because 9 different from 0 is positive 9 down to negative 9. So what you do for a scale doesn't matter. Just make sure you make things fit. I'm going to go by a scale of 2, because that's what's going to fit on my graph. And you're going to want to make sure that when you're doing this, you're better off making your scale of your x-axis and your y-axis the same. Do they have to be the same? No, but if they're different, your circle's not going to look like a circle. It's going to look like an oval, aka an ellipse. So, I would say make your scale the same on both graphs and make sure you're indicating the scale on there. If I'm counting by 2s, I need to put 2s on there. I don't honestly care if you label everything. I typically go at least every other, which you've heard me say before. Which I chose an odd way to go about it, because I labeled the first one and then did every other. To make a circle semi-accurately, after you've got your graph drawn out, you've got your scale, you plot the point for the center. And then you go up, down, left, and right. The radius from that point gives you 4 points to work with to kind of make your circle with. To the right from negative 2, 9. A distance of 9 away from negative 2, I get a positive 7. From negative 2, 0 going up, I'm at negative 2, 9. Down, I'm at negative 2, negative 9. To the left, I'm at negative 11, 0. And then I just try to make it as circle-y as possible. Yes, sometimes it ends up looking like a football. As long as it doesn't look like a diamond, I'm okay. Make it a little bit curved. Okay, we're going to do one more like this, and then we're going to change up the instructions. y plus 2 quantity squared plus x minus 1 quantity squared equals 24. Now the first problem, I did like this. I did this rewrite into a true standard form. If you want to do that, you can, but you don't have to. So I'm not going to on this one. Center. Subtracted from the x is a 1. Subtracted from the y is a negative 2. Center I've got. Again, one of the most common mistakes I see is people accidentally getting the negatives backwards, or occasionally they flip-flop the x and y. The second most common error I see is popping up with the radius, and people tell me that the radius is 24. What is 24 actually? Radius squared. To get rid of squared, you know by now, you take the square root. Does it make sense to have a positive or a negative radius? Radius is a length. Simplify the square root. 24 divides by the perfect square. 4. It's 4 times 6, so the radius is 2 root 6. And we graph it. So since my center is at 1, negative 2, I'm going to move to the right 1. I'm going to move down 2, so I'm going to need a little bit more extra room on the right side and below. Not a whole lot of extra room. You can always center your axis. I just don't. With the center and radius of this, I could probably count by ones and be perfectly okay. If you do not put a scale on your graph, I'm going to assume that your scale is 1. So, since I'm going to be counting by ones, I'm not going to put a scale on it. First thing you plot is still the center. Right 1, down 2, there we go, there's my center. Then, radius above, below, left, and right of that point. How do I move 2 square roots of 6 up, down, left, and right of anything? Remember how it was a sketch? Do sketches have to be perfect? No. What's the square root of 24 as a decimal? So probably about 4.9, because again, we're graphing. Do I need to go to 2 decimal places for graphing? Probably not. 1 decimal place is going to give me an idea of, from this point, I'm going to go up about 4.9, left about 4.9, right about 4.9. Okay. 1, 2, 3, 4, not quite 5. 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 Decimals are your friend. I apparently did not make my scale evenly spaced because mine kind of looks a little bit on the eggish side. So, determining center and radius and graphing, okay. Nothing too scary there. Now, on your homework, they might continue to ask you to graph these next ones. you graph them the exact same way. You plot the center, you move with your radius. So on these next ones, I'm not gonna write that you should sketch the graph, but again, pay attention to what the book actually says when it comes to your homework assignment on if it wants you to sketch those ones or not. On these ones, we are going to write an equation in standard form. For the following circle. Now, with this, they're going to do a number of different setups. They could give you a picture, identify the center, identify the radius, start counting. If I give you a picture, you should be able to say, okay, this appears to be the furthest apart, this appears to be the furthest apart, let's go to the middle, there we are. Radius. Well, this is at -2, this is at 7. Different distance between those. When you're talking about horizontal and vertical distance, just start counting. You don't have to do anything fancy. I'm not going to do an example of that. I know you're capable. We're just going to talk about the 3 main examples you're going to see. Sometimes the most basic time, they're going to give you the center and they're going to give you the radius. To which the only thing you have to do is plug into the formula and simplify what you can. When I say simplify what you can, I still want it in standard form, which means we're still going to have parentheses squared and parentheses squared. We're just not going to leave things like minus negatives or numbers squared. So, x stays x, just like any other equation. X and y stay x and y. Is it -3 or +3? Close that square. Plus y. Technically it's -5. We're not going to leave it like that. I'm just writing out the basic generic form first. Equal to radius squared, so 7 squared. This is the very generic form. The simplified form, the answer I'm looking for, like I said, the only thing you're really simplifying is minus negatives and numbers squared. This is the type of answer I'm looking for. Given the center and the radius. We okay with that? I hope. They won't always be quite that easy. Oftentimes they're going to give you different options. They're going to give you a center, and they might tell you that it goes through a specific point. The two things that we need to write the equation of a circle is the center and the radius. We have the center, we're good there. We don't have a radius. Radius, by definition, is the distance from the center to the edge of a circle, to a point on the circle. If I'm telling you that it's going through the point -1, 0, I'm telling you a point on the circle. Which means, to find my radius, I need the distance between these two things. If only there was a formula for that. Maybe a distance formula. Distance formula, square root of y2 minus y1 squared plus x2 minus x1 squared. That was part of the notes on Friday. These are the two coordinate points I'm using. I don't care which one's point 1, I don't care which one's point 2, you just start plugging in. You might not actually want to use D though in hindsight, because what does D typically refer to on a circle? Diameter. D stands for radius. Not quite. Okay, so I would change it to R. You don't have to, as long as you know what you're finding. Okay, y2 minus y1, I'm going to use this as my y2. So 0 minus a negative 4 quantity squared plus x2 minus x1 negative 1 minus 2 quantity squared. 0 minus a negative 4 is 4 squared plus negative 1 minus 2 is negative 3 squared. And if I type it in like that, I've got issues. Need parentheses around the negative 3. Technically, you can put it around the 4. It doesn't hurt. But remember, PEMDAS doesn't get rid of the parentheses until you've taken care of the squared. 4 squared is 16. Negative 3 squared is a positive 9. That's why we needed the parentheses. Add those together, I get 25. Radius is 5. So, now that I know my radius, x, now it says minus h, is h2 negative 4, negative 1, or 0? 2, make sure you're grabbing from the center, not from this point. This point does not go into the equation, it was only used to find the radius. X minus 2, quantity squared, plus y minus negative 4, so I can change it to a plus 4, equals, remember it's r squared. R was 5, so r squared is 25. Still nothing too scary? Final example. Last common thing that they give is diameter endpoints. Again, I need two things to write the equation of a circle, center and radius. I have neither of them now. Why midpoint?
Because the diameter stretches across the whole circle, so
Yes, diameter goes across the entire circle. The center of a diameter is the center of a circle because from center to edge is a radius. So it's got two radii. So yeah, midpoint formula between those will give us our center. Midpoint formula. x1 plus x2 over 2. y1 plus y2 over 2. Okay, so 7 plus negative 1 over 2. 6 plus negative 8 over 2. Remember, add your numerators before you go dividing. 7 plus a negative 1 is 6. 6 plus a negative 8 is negative 2. Simplify if possible. If not, leave them as a fraction. Okay, technically, if you give me a 0.5, I'm not going to be upset, but I prefer the fraction. 3, negative 1. Be careful, midpoint formula adds while distance formula subtracts. It's another common mix-up. So, that's my new center. Not my new center, that is the center. I need the radius. To find the radius, I've got a couple of different options. Some are better than others. One thing that I see people often do is they find the length of the diameter by finding the distance between these two and cutting it in half. Save yourself the work. Find the distance between one of those 2 points and the center. I don't care which point you work with. I personally would use 7, 6 because they're positives. Okay, y2 minus y1, negative 1 minus 6, close that squared, plus x2 minus x1, 3 minus 7, close that squared. Don't lose your parentheses. Don't forget it's a plus sign in the middle of distance formula. It's only minuses in the parentheses. Don't forget that when you square a negative, it becomes positive. Now, when it comes to finding your radius, oftentimes what people are doing at this point is they're trying to simplify the square root of 65, which first off doesn't actually simplify, because 65 is 5 times 13. But also, if I don't specifically ask you for the radius, then you don't have to simplify that, because you're about to plug it into a formula where you're going to square it. Save yourself the headache. It's a heck of a lot easier to square the square root of 65 than to square a simplified version of it. More easily understood, if you went through the work and found that the radius was 2 square roots of 6, it's a heck of a lot easier to square the square root of 24 than it is to square 2 square roots of 6, even though they're the same thing. So, if that just simplifies, great. Unless I ask you for the radius, don't simplify it. If I ask for the radius, then do so. X minus, make sure you're grabbing from the center, 3 quantity squared, make sure this is a plus sign, y minus, negative 1, in other words plus 1 squared, equals, if that's r squared is therefore 65, because the square root squared cancels out, we're left with the 65. How are we feeling about circles? Generally, it's pretty straightforward. Okay, we are on page 610. Please write day 1 because we're going to be on 610 tomorrow as well when we do something slightly different with our circles. Okay, when we do the same thing with our circles but in a harder way. Questions 12 through 22, those ones are even. 23 through 28. And 31 through 34. It's a bit of a mixture of things.